Did you know that you don't have to remember the trigonometric identities? Actually, ordinary algebra together with one crucial formula will derive them for you. This crucial formula is the famous Euler's formula, which expresses the exponential function of a purely imaginary argument as a decomposition into the real and imaginary part. In that decomposition, the coefficients are cosine of x for the real part and sine of x for the imaginary part. Here, I is the imaginary unit, whose defining property is that its square is equal to -1. If you're already familiar with imaginary numbers, that's fantastic. If not, don't worry. Just accept these axioms for now. The rest will be ordinary algebra. Using the Euler's formula, we solve for sine x and cosine of x. We compute e to ix plus e to minus ix is equal to cosine of x plus I sine of x plus cosine of minus x plus I sine of minus x. Since cosine is an even function and sine is an odd function, the sines cancel and the cosines add up. We get that cosine of x is e to ix plus e to minus ix all over 2. Similarly, we compute e to ix minus e to minus ix and find that sine of x is e to ix minus e to minus ix all over 2i. Now, let's substitute u for e to ix. E to minus ix becomes u to minus 1. Rewrite the formulas for sine and cosine. We are now ready to derive our first trigonometric identity. We will go with a classic, sine of 2x. Note that e to 2ix is equal to u squared, and e to minus 2ix is equal to u to minus 2. Therefore, sine of 2x is equal to u squared minus u to minus 2 all over 2i. Here comes algebra. The difference of squares, a squared minus b squared, is equal to a plus b times a minus b. We apply this here to get 1 over 2i times u minus u to minus 1 times u plus u to minus 1. The first part is just sine of x. The second one is 2 times cosine of x. We find the familiar sine of 2x is equal to 2 sine of x cosine of x. What about cosine of 2x? What do we do with u squared plus u to minus 2 over 2? Remember the formula a plus minus b squared is equal to a squared plus minus 2ab plus b squared? If we add a plus b squared to a minus b squared, we get twice a squared plus b squared, because 2ab cancels out. Let's use that to our cosine. There's an extra 1/2 factor, and then u plus u to minus 1 squared plus u minus u to minus 1 squared. Factoring 1/4 inside the brackets, we find u plus u to minus 1 over 2 squared plus u minus u to minus 1 over 2 squared. Now, keep in mind that I squared is equal to minus 1, so I can change the sign before the second term to minus and insert I in the denominator here. Looking back at the expression for sine and cosine, we extract the well-known formula. Cosine of 2x is cosine squared of x minus sine squared of x. You might say, fine, I already knew these formulas. Check out one more example to see an easy derivation of a formula which you probably don't have memorized. Consider cosine of 3x. This is written in our notation as u cubed plus u to minus 3 over 2. The algebra we need here is a formula for the sum of cubes. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Apply this to the cosine. We get 1/2 times u plus u to minus 1 times u squared minus u times u to minus 1 plus u to minus 2. We identify the first piece as a cosine of x And in the second bracket, we see u squared plus u2 minus 2, which is 2 times cosine of 2x, and u times u to minus 1 is just 1. Finally, cosine of 3x is equal to cosine of x times 2 cosine of 2x minus 1. As you try to derive more identities, you will see that it usually comes down to the ordinary algebraic identities. I hope you find this useful. To learn more, check out Logosphere Tutoring. We offer one-on-one tutoring in mathematics and physics on academic and high school level. The link is in the description below. Like and subscribe.